So we're starting now to get into using all the stuff we've done in a context. Okay, so we're just going to have a little look at a standard context that comes up quite often. Okay, so patient suffers from a short fever, given to you with a temperature, given by that function there, number of hours since the onset of the fever. So what is dy by dt? What does dy by dt represent in this situation?
Like the differentiated function?
Yeah, so it represents the rate of change of temperature so in other words, it's how fast is the temperature changing with respect to time. Is that right? So you guys can all tell me what dy by dt equals given this equation, hopefully. So dy by dt would be equal to 0.3 minus 0.02t. Is that right? You happy with that? But what does that actually represent? It represents the rate of change of temperature with respect to time. So how fast is the temperature changing with respect to time? Does that make sense? Because when does the temperature reach its maximum? The temperature reaches its maximum when the rate at which it's changing is 0. Okay, so this one here implies that dy by dt equals 0. So in other words, 0.3 minus 0.02t is 0. How do you solve that one? 0.3 equals 0.02t. Divide by the 0.02. So t is 15. Is that my answer? No. No, because when does it maximum? That is when, isn't it?
No.
That is when?
No.
Yes. When is a time reference. If you say when, you're talking about a time. If you're talking about what, you're talking about the quantity. So, in other words, in here, when t is 15, y will equal what? You were happy with that? Okay, so. Degrees. Everyone happy with that? Probably should put units there. So the next part, C here. When does the patient's temperature return to normal? How are you going to solve that one? How are you going to solve that?
0.3t minus 0.01t equals 2 equals 0.
Yeah, I think so. Yep. So you're going to substitute into this equation here. So if I bring that one down here, that's going to be 37.4 plus 0.3t minus 0.01t squared. That is equal to the temperature of the body, eh? So at what times does the temperature of the body equal that normal temperature, 37.4? Trying to solve that equation. How do you solve that? Take away 37.4 from both sides. Left with 0 equals 0.3t minus 0.01t squared. Solve that equation. Factorise that. Lowest common factor is 0.01t. So I'll take that out the front. Ends up with is 30 minus
T.
And so if I, so T is 0 or T is 30, so after 30 hours. Does that sort of make sense?
Yep.
Happy with that? So, like, is this skill here, is this a hard skill? This one right here? Finding the gradient function to be 0, finding a maximum or a minimum. That's what you've just been doing, eh? But with no context. So here we're just going to look into some contexts now.